All right, we're going to start off with something that you've done before. We're going back to our rules, things we learned in geometry about right triangles. And the first topic is going to be Pythagorean theorem, and then the second one is special right triangles. So we're going to do some practice problems to kind of review those concepts. But before we do, I want to make sure that y'all remember a couple of things when you did study triangles in geometry. We know that right triangles are very useful in problem solving because there's a special relationship between the sides and the angles of right triangles. But I want you to recall that the largest angle of any triangle is always across from the longest side, and the smallest angle is always across from the shortest side. That's going to come into play later on. And remember that the sum of the angles of any triangle is always 180 degrees. And the longest side of a right triangle is called the hypotenuse, and it is always across from the right angle. All right, now then, when we learned about right triangles and how to solve for missing side lengths, we talked about using Pythagorean theorem, where a squared plus b squared equals c squared. And c represents the hypotenuse, and a and b are the legs. So the sum of the square of the legs is equal to the square of the hypotenuse. So that is our first rule. We're going to go ahead and talk about that and practice using this formula. So let's skip down here to number 1 for the practice problems. All right, the first thing it says is to solve for x and round to the nearest tenth place. Well, x, you got to think about, does it represent a leg or a hypotenuse? Hypotenuse is always across from the right angle, so this would have to be c, and these would be a and b. It doesn't matter which leg is a and which leg is b. Plug it into Pythagorean theorem. 6.3 squared plus x squared equals 15.4 squared. All right, the next thing we're going to do is we are going to square our leg and our hypotenuse. So we need our calculator, and I can't seem to get mine to turn on. Let's see. I had to grab another one. So we're just going to plug this in. We've got 15.4 squared, and I am going to subtract 6.3 squared from both of those sides. Now, keep in mind, when you do this, you have to square before you subtract. So we've got 15.4 squared minus 6.3 squared. And that gives us 197.47. Well, that's not the length of our leg because there's no way that would even close. It wouldn't make a triangle. So the last step is to make sure you take the square root of both sides. And then the square root of our answer is 14.1 if we're rounding to the nearest tenth place. So x is equal to approximately 14.1, and in this case we're looking at miles, so we can write miles here. All right. Determine if this is a right triangle. Well, now we can also use Pythagorean theorem to prove triangles are right, acute, or obtuse. So what you have to do when we talked about, remember the longest side is always the hypotenuse. We've got 16 is definitely longer than 10. Let's see if it's longer than 2 root 39. So 2 root 39 is about 12.5. So yes, so 16 is definitely the longest side. So we're going to use it as side C, and we're going to use these two sides as our legs for A and B. So we're just going to go ahead and say is 10 squared plus 2 root 39, and we have to put that entire expression into parentheses to square it, is equal to 16 squared. Well, I know 10 squared is 100. 2 squared is 4. and the square root of 39 squared is 39. So 4 times 39 would give me 156. And I know 16 squared is 256. So since the sum of the square of the two sides here equals the longest side, the square of the longest side, we can definitely say that this is a right triangle. Yes, right triangle. Okay. Now, let's go back and take a look at our special right triangles. Special right triangles, if you remember, there's two kinds of special right triangles. There's the 45, 45, 90, and there's the 30, 60, 90. And all of these triangles, every 45, 45, 90 triangle is similar. Every 30, 60, 90 triangle is similar. And there's a special relationship between the length of the legs and the hypotenuse, so that you don't have to do Pythagorean theorem. You only have to know one side length and you can find the rest of them. So it's just these two types that you have these special cases. Now, the way it works is on your 45, 45, 90, you've got your legs here. And your legs, if you take them times the square root of 2, you're going to equal your hypotenuse. So no matter what the length of your leg is, multiply it by the square root of 2 to get the hypotenuse. So the leg times the square root of 2 equals the hypotenuse. Now, you can work that backwards, and if you know the hypotenuse, then you would have to divide by the square root of 2 to go backwards to your leg. So you're going to be going backwards and forwards with that, that concept. The 30, 60, 90, this one, I always start with the short leg. The short leg is always across from the 30-degree angle. This is your short leg. Your long leg is always across from the 60-degree angle. There's your long leg. And then, of course, your hypotenuse across from the 90-degree angle. Now, I always start with the short leg. And if you don't know the short leg, go find the short leg, because the other two sides are based off of it. If you know the short leg, you multiply it by the square root of 3 to get the long leg. If you need the hypotenuse, you double the short leg to get to the hypotenuse. Now, remember, the square root of 3 is less than 2. It's like about 1.7. So a lot of people think of that 3 and forget that the square root of 3 is smaller than 3. So that's why you use 3 on the short leg, on the long leg, because you're using the square root with it. The hypotenuse is the longest, and it is doubled times 2. So let's go ahead and look at some practice problems on page 3. It says leave your answers in simplest radical form. So we're looking here, we've got a 45, this would be 45, it would have to be 90 triangle. So that means it's isosceles. We have two congruent angles, we have two congruent sides. So this side over here is 2 root 2. There's no math involved in this. We just know that they have to be the same. Now, in order to find the hypotenuse, though, this is your hypotenuse, we're going to have to multiply the leg times the square root of 2 to get to the hypotenuse. This might challenge some of y'all on your radicals, okay? Simplifying radicals and such. When you multiply two numbers, one of them is they have radicals, you multiply your coefficients together. So that's 2 times 1, which is 2. And then you multiply your radicands, the number under the radical, together. And that would be that would be root 4. Well, I know the square root of 4 is 2, so really that's 2 times 2. And 2 times 2 is 4. So the length of our hypotenuse is 4. You don't have to show all this work. I just wanted to remind you of each individual thought process that gets you to this answer, though. Now, In number 4, we're working backwards, okay? We're given the hypotenuse, and we're looking for the 2 legs, and the 2 legs are going to be the same. So what we want to do, if we know that the hypotenuse is 2 times the square root of 6, and we know that x times the square root of 2 is equal to the hypotenuse, okay? We take the leg times the square root of 2 to get to the hypotenuse. Then we're going to divide both sides by the square root of 2. Now, here's where you need to be careful. When you are dividing with radicals, you can divide your radicands just like over here we can multiply our radicands. Do not divide a whole number with a radicand because they're not of the same value. The square root of 2 does not have a factor of 2 in it. But underneath the radical, they do. So root 6 divided by root 2, you can take out a factor of 2, root 2, so you're left with a root 3. So your actual legs are 2 root 3, and that would be the length of each one of those. So that would be your x and your y value. All right, looking at number 5. Here is, you're looking for your legs. Identify the short and long leg. Now this obviously is not drawn to scale. Since A is across from the 60-degree angle, this is your long leg, and it is the short leg times the square root of 3. This is your short leg. It's x. This is your hypotenuse, and the hypotenuse is 2 times x. It's 2 times the length of the short leg. So what I'm going to do is I'm going to go backwards to get to my short leg. So to find it, I am going to take 2x, set it equal to 2 root 2, and I'm just going to divide my hypotenuse by 2. You are simply just dividing it in half. So your short leg is just the square root of 2. Now, if that's my short leg, then my long leg is root 2 times root 3, which would give me root 6. So whatever your short leg is, multiply it times the square root of 3 to get to the long leg. All right, you've got some practice problems down here, about 10 problems that you're going to be working using these and leaving your answers in simplest radical form. And so you will enter your answers into the teacher-made link in Google Classroom to check your answers, just to make sure you're doing them correctly. And remember, the answers will be left in simplest radical form. So no decimals. Be sure you simplify the radicands and you reduce down if necessary.